Hello everyone, I am Pragati Patte from Sri Siddheshwar College of Engineering, Solapur, from Division B SYB. Today I am delivered a topic counters, applications of counters. Counters the rhythm of digital logic. What are counters and why are they important? Counters are sequentially logic circuits that can store and display the number of times a particular event for or process has occurred, or simply count in a predefined sequence. They are essential components in nearly all digital systems, providing critical timing, sequential, and control function. The ability to track event makes them fundamental building blocks for operations. Timing generate precise delay and clock signal. Counting track occurrence of event or pulse. Sequencing control the order of operation in circuit. Control manage system state and operational flow. Counter application in frequency division. Counters are widely used in frequency division, where a higher input frequency is divided by a specific factors to produce a lower output frequency. This is crucial for generating various clock signals from a single master associate, oscillators, enabling synchronization across different parts of digital system. But on its high frequency input, master oscillator signal, counter division, reduced pulse rate, lower frequency output synchronization, clock signal, using counters in digital clock and timers. Digital clock and timers heavily rely on counters to keep accurate time. A master clock signal feeds into counters which increment at specific interval. These counters then drive display segment or trigger events, providing precise timekeeping function. This fundamental application demonstrates the counter's ability to transform high-frequency pulse into human reactive time format. As- also, oscillator pulse generates high-frequency signal. Counter increment divides frequency for second. Timer logic drives minute and hours. Display output show current time. Event counter in industrial automation. The industrial automation event counters play a vital role in monitoring process and controlling machinery. They are used to count protect on a assembly line revolution of a motors, or even the number of time a sensor is triggered. This data is then used to trigger actions such as stopping a conveyor belt after a certain numbers of items, ensuring efficient and precise manufacturing operations. First one is product batching, counting items for packaging, machine cycle control, tracking operation cycle of maintenance, quality assurance, detecting defect based on code counters in analog to digital conversion. Counters are integral to certain types analog to digital converter, particularly in successive approximation and dual so in this architecture, a counter is used to generate a digital output. Then is the converted back to analog and compared with input analog signal. The counter iterates until the two signals match, providing a digital representation of the analog input. Digital output converted value comparison digital versus analog counter iteration adjust digital value analog input signal to be converted sequential generation with counters are perfect for generating specific sequence of digital pulse or state which are vital for controlling sequential operations in complex systems. By designing synchronous or asynchronous counter with specific state transition, engineers can create precise control signal for tasks such as stepper, motor control, data multiplexing, or triggering specific events in a predefined order. This pre- this predictable behavior makes them ideal for intrinsic timing diagrams. First, define sequence, desired output state, design counters, logic for state transition, implement circuit, build with flip-flop and gates, generate output control signal for task. Counter-based control system example and benefits. In control system, counters often serve as the backbone of managing sequence and state. For instance, is traffic light controllers counters dictate the timing for each light state change. In washing machine, they control the duration of wash, rinse, and spin cycle. The benefit include high precision, repeatability, and easy of implementation, making them a reliable choice for automated processes where accurate timing is paramount. Traffic light regulate signal changes, precise timing, consistent cycle, washing machine, control cycle duration, automation stage, ubiquitous application of counter. Counters are not just theoretical concepts, they are fundamental to countless real world applications. From the microsecond precision in computer process to timing in your household appli- appliances, their versatility makes them indisable. They are the silent workhorse that enable synchronization, measurement, and control across almost every piece of digital technology we interact with daily. Customer electronics used in ovens, microwaves, and entertainment system for timing and sequence control. Computing essential for CPU clock cycle, memory addressing, and instruction sequential. Telecommunication used for frequency synthesis, data packing, counting, and timing in communication protocols.